All right, so this is CS50, and this is lecture 2, our continuation of C. And for the next several weeks, we're going to keep using C, but we're going to focus less on the language and the syntax, which we'll get experience with over time by way of the problem sets, and more on the ideas and more on the problems that we can solve. But before we forge ahead with anything new, let's take a quick look back at where we left off and what we'll sort of assume for today's comfort level and ask any and all questions along the way. So in order to program last time, we needed a tool. And that tool was this thing here, CS50 IDE. If you haven't typed in already, you probably will this weekend for problem set 1. And this will be a web-based programming environment that's got all the requisite tools you need in order to write code, compile code, and then starting today, debug code or find mistakes in code. But this is requisite because it's not sufficient to just write this. What do we call this, generally speaking? Yeah, so this is source code. So this is code. When someone says, I write code, they write stuff like this. And this is particularly a language called C. But of course, computers don't speak C, and they don't speak Java, and they don't speak Python or C++ or any of the languages with which you're familiar. They only understand what at the end of the day? Yeah, so binary. So binary is, of course, zeros and ones, otherwise known as machine code in this context, insofar as it is code. It's instructions that implements some problem-solving techniques, but it's just zeros and ones that computers understand. So we needed a tool to get from A to B, and that was called what? Yeah, a compiler. So a compiler, of course, does this for us. Source code is the input. Compiler is the program, or really the algorithm, albeit in the form of a piece of software. And then the output is machine code, zeros and ones. And for our purposes, we're not going to worry about how we get from step A to B per se. We'll want to use the tool. But this is another area unto itself in computer science if you want to understand how compilers work and how humans got from literally zeros and ones to something called assembly code to higher level languages. You'll see a glimpse of that in CS50. But it unto itself is a whole field that might prove ultimately of interest. But this, more mechanically, is how we compiled code. Clang is a compiler, stands for C language, and it's just software that some humans wrote some years ago. And there are alternatives. If you've ever used Visual Studio in the Windows world or GCC in the Linux and Unix world, there's bunches of other compilers. We just happen to use Clang, since it's pretty popular. And then that second command is even stranger looking, but it represents the act of doing what? ./a.out. Yes, over here. Yeah, running the program, exactly. So ./a.out is a cryptic way of running a program, but it's like the textual equivalent of double-clicking an icon. And a.out is just like the default name you get, assembly output or assembler output, when you compile a program without specifying its name. But we were able to specify a name. If you introduce a technique called command line arguments, you can be a little more precise, clang-o for output, then any word you want. In this case, I went with hello, and then the name of the program or the file that you want to compile. But this, of course, gets pretty tedious. And in fact, there's a missing step. Sometimes when you want to write a program, it suffices to compile it exactly as that. But let me go ahead and do this. Let me go ahead into CS50 IDE, and let me go ahead and briefly do the following. File new, and let me go ahead and save this as hello.c. And just for memory, I'll quickly recreate that same program, int main void, and then we had printf, hello, comma, world, and then just for good measure, \n, which means move the cursor to the next line. And now I'm going to go ahead and save that. If I go ahead now and run clang hello.c, looks good, and ./a.out, that looks good too. But recall that we introduced some other functions the other day as well, like getString and getInt, and we'll see bunches more before long. And if I do that, notice that I have to do a couple of things. So if I want to do like string name getString, and then quote unquote name to prompt the user, recall that the left-hand side says, hey computer, give me a variable that's going to store a string, call it name. Could have called it anything. I could have called it s. But why might it be arguably better to call my variable name instead of string, or s rather? Yeah. Yeah, it's just clearer, right? It might be a very marginal, nitpicky detail, but it's just clear. And when our programs get bigger, it's just nicer to be able to read words and understand implicitly what they mean without having to think through what x or y or s or whatever it actually is. On the right-hand side, meanwhile, we had this function getString, whose purpose in life is to go get a string from the user from his or her keyboard, prompting them with a word like name, and then return it, just as Sam handed me back a slip of paper with a name on it. But there's a catch. It's now no longer sufficient to just adapt my code for this new approach. And I had, again, to change that second line, I had to give a placeholder which is %s. And if that's a little cryptic looking, just kind of think of it like a Mad Lib, if you're familiar with those, where there's just like a fill in the blank here. And all %s is doing is saying, put a word there. What word? Well, whatever comes after the comma, whatever variable or value is there. So that's good, but a couple of things can go wrong. And let me point those out so that you don't perhaps trip over it yourself on your own. Let me go ahead and do clang hello.c now that I've made these changes and saved them. Bunches of errors all of a sudden, even though I've not changed all that much code. Again, rule of thumb from last time should be, even if there's lots of error messages, always look at the first one first, because the rest might just be kind of a resulting cascade of errors, only one of which is important, which is the first. Now it says use of undeclared identifier string. Did you mean standard in, which is something else altogether? I didn't. I meant string. And it turns out that string is a feature of the so-called CS50 library. So this is one of these training wheels we're just going to use for a few weeks until we dive in underneath the hood of strings too. But in order to use anything from CS50, what did I need to add to my code too? Source code, yes, but what else? The library. And the library was the CS50 library, and that means there's a file somewhere on the computer in the IDE called cs50.h, so-called header file. More on those in a bit. And so I did forget that detail. But suppose you don't recall that yourselves. Well, you might recall from one of our orientation sessions that CS50 has tools with which to help for this too. You don't have to turn to this course's online discussion forum. You don't have to go to office hours necessarily for error messages like this. If you can't quite wrap your mind around what's happening, go ahead and do this instead. Instead of just running clang hello.c, do something like help50 clang hello.c, where help50 is a CS50 specific command, sort of a virtual teaching fellow, if you will. And if we recognize your error messages in yellow at the bottom, we'll highlight the first one, and then we'll try to give you advice like you might get in person. So by undeclared identifier, clang means that you've used a name, string, on line 5 of hello.c, which hasn't been defined. Did you forget to include cs50.h, in which string is defined atop your file? So we'll generally try to prompt you with rhetorical questions that hopefully are correct in leading you toward the right solution. So OK, that jogged my memory at least, even if I'm not yet 100% comfortable with what these lines really are doing. And we'll tease that apart more today. But it feels like I'm trying to do this. But it turns out there's one other gotcha here. Clang hello.c, enter. Dang it. Well, actually, this is a net positive, right? Fewer error messages, it would seem, but now one we did not see the other day. Undefined reference to get string. So it's kind of similar in spirit, like something is not understood, but it's different wording, certainly, and I'm not quite sure what that means. But it turns out that it's not sufficient just when using most libraries to use include cs50.h or other header files, as we'll eventually see. That just teaches the compiler that something exists. It was like briefly last time when we talked about prototypes, where I put a little one-liner that just said, by the way, this function's eventually going to exist. That's what the header file's doing. It's like a promise to Clang, this shall exist. But there's a second step. You actually have to feed Clang the zeros and ones that implement the CS50 library that you, of course, did not create yourself, but we did pre-install in the IDE. And there's a separate way of doing that. Rather than just do clang hello.c, you have to do what's called linking your code against that library, at least if it's a third-party library that doesn't come with the computer. It came from humans like us. So this now says, hey, Clang, compile hello.c, but link it against the CS50 library, which means take my zeros and ones, take CS50's zeros and ones, combine them, and then give me my actual program to run. And so that's going to be a key ingredient. And help50 could guide you toward that solution. But if I hit enter now it seems to compile /a.out. My name shall be David. Enter. And it says, hello, David. So again, don't get hung up ultimately in office hours and problem sets on these kinds of errors. You're going to hit these bumps from the get-go. But just realize, look for sort of familiar words. Use things like help50. Reach out to the course online. And just get over those hurdles. Because at the end of the day, the interesting stuff's going to be the logic of the programs and the actual problems we're trying to solve. So what is it that's actually then going on here underneath the hood? And frankly, this is very quickly becoming tedious. So how do I automate some of these processes? Because it's very easy to forget this, and it's just very boring to continue to type so many commands. Well, recall that there was a shortcut we talked about the other day, which just kind of hides all of these details. You don't need to remember -o. You now don't need to remember -l CS50. What do you do instead to make a program? Yeah. Yeah, so make, it's not a compiler itself. It's just kind of a helper program that knows how to run a compiler for you. So frankly, the simpler approach is just to do that, make hello. And the reason it outputs so many more words is just because we have, in anticipation of teaching the semester, sort of pre-configured it with command line arguments, additional words, that we expect you're going to need at some point. And this just saves you the trouble of having to futz around with a manual to figure that kind of thing out. But that's why it looks cryptic. But notice, this is really the most important word, hello, followed by hello.c. And those are your two ingredients. All right, so what's going on then underneath the hood there? Well, it turns out that even though we can simplify the command structure, it's actually doing quite a bit for us. And this is the process of compiling, but that was kind of an oversimplification, or put more intelligently, like an abstraction. There's actually quite a few steps that go on underneath the hood, one of which is called preprocessing and compiling and assembling and linking. So let's do a quick dive down here, but then we'll abstract away just so that you've seen what's going on. But henceforth, we can just take for granted that all of this is happening. So here is source code, same program as the simplest version we had a moment ago. And ultimately, I need to get this to machine code. Well, let's see if we can't just visualize how we get from point A to B without completely abstracting it away with just those big arrows. So this is my source code. And it turns out that the very first step of turning source code into machine code in the world of C is you first run what's called a preprocessor. You don't do this explicitly, although you could if you were really low level and interested in it. But what the preprocessor does essentially is anytime there's a line of code that starts with a pound sign or a hashtag these days, that's what's a special command that gets essentially replaced with the contents of the file, at least in this case. So somewhere on the IDE is a file called literally standardIO.h. And so hashtag include means go get that file and essentially copy and paste it here. And so when you preprocess your code, this yellow line here becomes something like this. And I'm doing dot, dot, dot because it's dozens, if not hundreds of lines long. But there's one juicy line in it, which is the little clue to Clang that printf shall exist. And that's why you need standardIO.h. So that's essentially, for our purposes today, all the preprocessor does. It does these kind of find and replace style operations so that now your file, without you knowing it, suddenly became much bigger because it's got other lines of code that someone else wrote. And then your code remains right there as it was. But the next step, after preprocessing, is something called compiling itself, which technically the compiler, if we really want to be nitpicky and look at its formal definition, is actually taking these yellow lines, your source code and someone else's perhaps, and converting it into something called assembly code. And this is a language that humans kind of sort of still do, but back in the day really did program in. And in fact, if you have a computer with an Intel CPU, a brain made by Intel, inside of your computer, there was and still is, a big user's manual that tells programmers around the world that this Intel CPU understands the following instructions: add, subtract, multiply, divide, all the basics, and then things like move numbers from here to here, read numbers from here to here, just move stuff around in the computer's memory. And so even though this really looks cryptic, even to me, since I am by no means an expert at assembly language, certainly all these years later, you can see words that kind of sound familiar, like MOV suggests moving a value from one location to another. Sub alludes to subtraction, so subtracting one number from another. And without really thinking this through carefully, I'm not really sure what's going on yet, but I do see a familiar word down there, call printf. And so long story short, what the computer, or compiler specifically, has done is it's taken my more user-friendly C code, converted it to something that's a little closer to what the machine understands. But it's not there yet, because the machine only understands zeros and ones, so there's another step called assembling. And the assembling process simply takes assembly code and converts it to zeros and ones. Now we're down to the zeros and ones. And what's amazing, if it's interesting in the first place, is when you run Clang and hit enter, all of this is just happening instantly. And you're getting these zeros and ones as output. But I've left room on the other side because all we've done is convert my code from source code to assembly code to machine code. What needs to now be merged in, so to speak, for that hello world program? Yeah, so we still need like standard IO, the standard IO library that has printf. So the next step is to take a whole bunch of zeros and ones from somewhere else on the system, combine them until this is the file containing a.out or hello, whatever you called your program, and that ultimately is what the computer understands. So that is a very low-level detail. Thankfully, we learned in the very first lecture this notion of abstraction, which means even as you dive in underneath the hood and sort of understand how we're building up, now, henceforth, literally every minute hereafter, that whole mouthful just becomes compiling. And indeed, that's what most people in the programming business refer to as compiling, is all of those several steps. But that's all that's happening. Feels like magic, but it's just one step after another gets us closer to our goal.